Today YouTube, I'm going to start off with squaring some numbers. Yeah. So let's start with, 2 squared. Well, 2 squared equals 4. But now we're going to take a series of numbers around 2, near 2, and we're going to square those. I'm going to write a few down. I'm going to square them, and I'll put the paper up to the camera. So, start with 1. 1 squared. That's equal to 1. And then we could do 2 1/4. So you could write that as 2.25. But you can write that as a fraction, and that's 9/4. And you square that, you get 81/16, if I'm doing this correctly, which should be equal to, that should be equal to 5 1/16. Yeah, I think that's 5 1/16, because 16 goes into 85 times, so that's 5 1/16, and I don't think that reduces into a nice expression. Like, I think a 16th is some repeating fraction. But we could do 1 1/2. So 1 1/2 squared is equal to 3/2 squared, which is 9/4, which is the thing we just did. That's 2.25. That's a coincidence. I didn't intend that. We could square 3. That's equal to 9. And we could square 2 1/2, which is equal to 5/2. So we square that, we get 25/4, which is equal to 6.25. That's just a bunch of numbers I'm squaring, and I'm looking for a pattern here. I'm looking to understand the nature of squaring numbers. So really my baseline is 2 squared. That's my baseline, and all of these are just numbers near 2, and so, like, if you start paying enough attention, but not too much attention, you'll see that, like, let's take this one, 2.25. So that is about 5. It's close to 5, which is 1 away from 2 squared, which is, it's 4 times 1/4. It's 4 times the amount that you added to 2 away from 2 squared. And if you look at, like, 1 1/2, that's 2 minus 1/2. So if this type of pattern is holding, this should be, 4 minus 4 times 1/2, which is like minus 2, and it's 2.25, so we're not too far off. If we look at 3 squared, that's 3 plus 1, so it's 9, and what I would expect from this pattern is 8. So it's not that far off. And the same thing's true of 1, which, like, if you're following this pattern, you subtract 1 from 2 and you multiply by 4. Sorry, to get 1 you subtract 1 from 2, and so you multiply that difference by 4, And so you should expect 0. And I mean, 1 isn't that far off from 0. 2.5. You're adding a half, so you should expect 6, and you get 6.25. You can see that this pattern holds to some extent. So here, let me rewrite these equations. I'm going to rewrite it as 2 plus h squared. And that's going to be equal to 2 squared plus 2 times 2 times h plus h squared equals 2 squared plus 4h plus h squared. So this is what all those equations look like. You're doing something like this. You know, almost, I said that it's equal to this part of it. But you see that there's that extra term, which is sort of like the amount that my formula was off by. You could see that, and you could see this in the list of examples, and you can notice it with this formula, that how off my formula is depends on how big h is. Now, let's say I started with squaring 2, but let's say I started with squaring 5. So let's just take 5, 5.5, and 4.5. So we have 5 squared is equal to 25. We have 5.5 squared equals I think that's got to be 11 over 2 squared, which is equal to 121 over 4, which is equal to like 30.5, and then 4.5 squared is equal to 9 over 2 squared, which is equal to 81 over 4, which is equal to 20.5. So this is like a similar thing, but now I'm doing it with 5. So, well, how far off are they from 25? They're about off by 5. And I added or subtracted a half from 5. So, it's the difference times 2 times 5. You know, almost like, let's do the h thing again. So it's like 5 plus h squared equals 25 plus 10 times h plus h squared. That's what we have this time. And last time it was 4h. So really, the place that this comes from is you're taking whichever number is your baseline number. My first baseline number was 2. My second baseline number is 5. And then you just double that number. And that is roughly how far off you go. But I said before that the closer you are to your baseline number, the more accurate you are. The opposite is also true. So like, if you take, well, I was just working with 5. So if you take, let's say, 8 squared, and you compare that to 5 squared. So 8 squared is 64. Based on what I said, you roughly expect, well, the difference between 8 and 5 is 3. So you roughly expect 25 plus 30, because that's 10 times the difference, which would be 55, and you get 64, which is off by 9. So sort of like, the further you go from your baseline number, the more this formula breaks down. But the general formula, I think, is interesting. It's just twice times your baseline number. And then you multiply that by how much you vary. And that gives you a rough approximation for how much the square will be.